this, first you have to know that a parallelogram is a four-sided figure that is quadrilateral whose opposite two sides are equal or parallel. Okay, so but whereas in rhombus all the four sides, rhombus is a type of parallelogram whose all four sides have the same length. Okay, so for example in this, no, suppose it is 3 centimeter, this will be also 3 centimeter and this will be 2 centimeter, like this. In it is for parallelogram. Okay, you have to remember this, parallelogram. And for rhombus all those, this A, B, C, D, this is A, B, C, D. This means, for example, suppose this is a 2 centimeter, this will also be a 2 centimeter, 2 centimeter, 2 centimeter, but these two will be parallel and this two will be parallel. Okay, so what the question is saying is that a parallelogram ABCD which is circumscribing a circle is a rhombus, which means that, for example, this is your parallelogram, this is your parallelogram, and circumscribing a circle means this. Since circumference of a circle means this outer part, no, this is called your circumference. Okay, this is your circumference, circumference, which is 2 pi r, and this is your area, which is pi r square. Okay, remember this. So what the question is saying is that a parallelogram, this is ABCD, no, a parallelogram circumscribing a circle, which is circumscribing a circle, is a rhombus. Okay, so we will assume this point, it is circumscribing in this point. Okay, this will be, let it be P, Q, R and S. Okay, so in that ABCD is a parallelogram. And what we need to prove? To prove that ABCD is a rhombus, we need to prove this. Okay, ABCD is a parallelogram which is circumscribing a circle. From parallelogram we can see that this AB is equals to CD, no, and similarly AD is equals to BC, no, we will write this. Okay, since ABCD is a parallelogram which is given, no, so we will write AB is equals to CD and AD is equals to BC. Why it is? It is because opposite sides of parallelogram are equal. Okay, now theorem, we will use one theorem. What it says is that tangents drawn from external point to a circle are equal, which means that, for example, there is one circle, okay, and there is one point, and from that point if two tangents are drawn, for example this is P and Q. Okay, these will always be equal. This theorem says that if there is one circle and there is one point, and if from that point two tangents are drawn, then the length of that will be equal. Okay, for example this is AP equals to AQ. One theorem says this. Okay, so we will use this theorem to prove this. Okay, so since it is written that from the theorem tangents drawn from external point to a circle are equal, so from this we can write that ds equals to dr. Now since this is a point and two tangents are drawn in a circle, so we can write ds equals to dr is our equation 1. So from here a, the other point will be this, as equals to ap, be your equation number 2. And the other is, from this point we can write bq equals to bp, no, from this bq equals to bp, so bq equals to bp can be written equation 3. And the other is qc we can write this now. QC is equals to CR. So QC equals to CR be your equation number 4. So we will add all this equation. Okay, adding 1, 2, 3 and 4. That is left hand side we will add in left hand side only, and the right hand side in the other right hand side only. Okay, so DS plus AS plus BQ plus QC is equals to DR plus AP plus BP plus CR. So from here what we can write, DS plus AS. Here where is DS? DS plus AS can be written as whole, no, AD only, no. So we will replace DS plus AS equals to AD. So similarly BQ plus QC can be written as here, BQ plus QC can be written as BC only, no. So we will replace it with BC. Similarly write it like this. Okay, DR plus CR plus AP plus BP. From this what we can write is same as left hand side, and DR plus CR. Here DR plus CR can be written as whole CD only, no. So we will replace it with CD, and AP plus BP can be written as AP plus BP can be written as whole AB only, no. So we will replace it with AB. Since we know that AD, see from here we can write AD is equals to BC, no. So we can AD plus we can write BC as AD only, no. We can write it in two ways. Okay, AD plus AD we can write, and the other we can write CD plus CD, no. Since why we can write like this, since that CD is equals to AB, no. So we write it CD plus CD. Okay, from here we can write it in two way, no, or else we can write AD as AD and BC as AD only, or we can write AD as BC plus BC, no, and CD as AB, no, AB plus AB. We can write it in two way, no, like this. So here we can write it in two way. Either we can suppose this is your equation, no, and AD plus BC. Since we know that AD and BC are equal, either we can write AD as AD and BC as also AD, or we can write BC as AD as BC and BC as BC. Okay, so from here what we will get is AD plus AD is 2AD and CD plus CD is 2CD, and from here BC plus BC is 2BC and AB plus AB is 2AB. From here what we will get, 2 will be cancelled, which is equals to AD equals to CD and BC is equals to AB. Since we already know that the two opposite sides are equal in parallelogram, no, since we already know that AB is equals to CD and AD equals to BC, no, these are two opposite sides of parallelogram, no. From to CD, your AB is equals to CD is already there, but what we got from here is AD is also equals to CD. So we can write, no, CD is also equals to AB and CD is also equals to AD, means we can write like this, no, AB is also equals to AD. And similarly from here, okay, BC is equals to AB, no, and we already know that this AD is equals to AD is equals to BC, we know that, no. See here, BC is also equals to AB and BC is also equals to AD, means like we can write AB is equals to AD, no. So we can see that AB is equals to AD. Since what we can write, AB is also equals to BC and BC is also equals to CD is also equals to AD. We can write from here, no, all the sides are equal. We can write, no, since we already know that two opposite sides of parallelogram are equal, but from the equation what we got is AB is also equals to AD and AB is also equals to AD. So we can write AB is equals to BC, BC is equals to AC, and what we know that parallelogram whose all sides are equal, is a rhombus. Thus, therefore, parallelogram ABCD is a rhombus. Hence,